Bicodemo is a data management office, and I'll share my screen here. We are funded by the National Science Foundation, and what they typically fund for scientific research is transformative. Oh, I'm clicking the wrong thing here. They fund transformative research, and so what that means for us is that every single data set that we get from a researcher is like somewhat new, somewhat experimental. And so we see a ton of variability in the data that we get in a number of states of research readiness. But essentially, we're funded to work with the scientists that receive funding to do their research to make sure that their data is publicly available and archived for everyone else to use. And so on the slide here, you'll see just a number of different types of data that we get. So images, video, all sorts of lovely, beautiful, well-crafted Excel spreadsheets with color schemes and merge cells and different types of formats. And ultimately, what we want to do is take all of that data and convert it into something that is a little bit more research ready, ready for an archive, ready for long-term use. And so we're thinking about how these observations will be used like 50 years from now when maybe Excel doesn't exist any longer. Right, and ultimately, this information ends up on our data catalog website where folks can then find the data and download it. Okay, so we typically process about 500 data sets a year, all sorts of variability, and our staff typically was writing ad hoc scripts or software to process those data. And that just became a challenge for a number of different reasons. And we really came to this realization that the knowledge about what a data set needs to be ready for the archive has a different shelf life than the software that actually processes it. And so we wanted to separate out the knowledge and the information or data about what a data set needs for the archive from this like code that might do that work but might not be around in 50 years from now. And this process is called declarative workflows. And so when we've been looking at Frictionless and working with it for a couple years now and really got interested in their pipelines code. So I put that up here on the screen in case you're interested. This is sort of like the schema, the philosophy, and then the code in Python that would help us sort of separate this sort of like information about what a data set needs from the code that actually executed it. So here on the screen,
Adam, 1 second. Sorry, not to interrupt, but let's just get a couple terminology things out of the way. We're gonna probably continue to use the terminology data package pipelines, and using pipelines. The actual packages at Frictionless are there's some change in the structure. So we actually do use also data flows, and we're gonna have to talk with you guys about how to adapt to the new Frictionless transform. But essentially, it's the same thing. So everything Adam says is applicable to the new Frictionless transform. It's the same kind of operations. Okay.
Yeah. So in essence, what these sort of declarative workflows are is that given a tabular data file, Excel, CSV, whatever that is, you essentially craft a pipeline, which is just a set of ordered named tasks that you want to perform on that data file. And Frictionless out of the box comes with a number of common transforms that you can use. And these sort of like named tasks act as a proxy for small snippets of code that actually perform the work. So the pipeline, which you see on the screen here, this pipeline spec.yaml, is sort of what you want to do in what order on the data set to then transform it. And then this code behind the scenes is proxied by these named tasks, essentially. And so the results of running the pipeline are two files. One, a datapackage.json, which just sort of describes some very lightweight metadata about the resulting file. And then ultimately a CSV file, which is the data that's been transformed. Okay, so essentially what we're doing is we want to separate what to do from how it's done. And the three big reasons behind that are sustainability, communication, and provenance. So sustainability is really just like, okay, we realize that the information about what to do has a completely different shelf life than the code that actually does it. Code comes and goes all the time, which we've seen over the past 10, 20 years, but data always remains. It's so much more long-lived. And so we want to capture that separate from the code. Secondly, in communication, these named tasks become almost like a shared language amongst our team. It's much harder for data managers in the team, if they need to solve a problem, to bring together their own ad hoc scripts on a data set and then talk each other through that. That might be because they have different experiences or different levels of expertise and different types of code. And so having this shared language just helps them communicate easier. It also gives our team flexibility. It sort of like shortens meetings because we all have this language that we all speak and understand. But also it gives us flexibility in that data managers can sort of hot swap in and out and work on each other's projects without much level of like onboarding. And then finally, provenance. And this is what I think is really cool here, is that because the pipeline, that declarative workflow, that ordered list of named tasks is essentially data and it's stored as data, we can query it and ask questions like, ooh, what processors did Amber run? Or, oh, I found a bug in the way that this particular task runs. Show me all the data sets that I use that task on. And this, thankfully, we haven't had to do that yet, but that becomes really critical down the line as you try to just sort of manage and curate data over time. And then finally, and I want to get right into the user interface so you guys can see this. Okay, why did we put a user interface over that? And it was really just to improve efficiency. And that really comes down to consistency. So that's consistency of the BecoDemo processes. So without the UI, the team could be executing these pipelines, on their laptops or all sorts of different computers. And so the UI sort of forces the data to be in certain places that we know about, that we curate, that we can manage, so that every data manager has that same experience and has those same expectations. There's no environmental variables that impact the process. And that just sort of helps consistency and reduces our technical debt. But the real efficiency is honestly speed. And that's really just, producing pipelines without like syntax issues or typos. You get immediate validation checks because you're in a web form. So you can use those sort of like client side checks on the inputs. But also you can visualize what you're doing. And this is really key for our data managers that are working with complicated data sets. It lets them see the data as it's being changed. And so with that, I'll turn it over to Amber so she can show you what it's like.
Yeah, all those concepts, I especially want to drive home the benefits of visualization. I think that can kind of be not as highlighted or sometimes downplayed in terms of like, oh, you need to be a real coder, you do everything on command line. And well, yeah, you can do that, but having a visualization allows for greater context, and you actually end up making better data management decisions, basically because you can see how the code you're running affects the data, which I'll show you. Let me share my screen. Can everyone see that? Nod if you can see. Okay, I'll make it big. Okay, so this is our laminar interface, which is, as Adam mentioned, built upon, it's a web application that is built upon data package pipeline and data flows. So I will get right into it and bring up a demo, a canned demo I've created. Let's start with one that's maybe a little simpler, a case, maybe only has one thing that has to get fixed. So the way this interface works is that each step that we add in this pipeline that's built vertically here, as Adam mentioned, is a kind of descriptive step that has a snippet of code behind it. Some of them are default out of the box frictionless transforms, and some are custom code that Conrad has expertisely written for us. And it's pretty seamless on the front end. So, but that's all managed with version control behind the scenes, so we know exactly what is happening, even though we don't have to worry about that on a daily basis. So let's walk through this one. This is coral temperature data that I'm going to load. we've actually connected this to a new Bigodemo submission system that we're currently in beta testing for. So I'm able to load our files from this submission right from our S3 bucket. But we can stage files directly from storage locations, other places if we have to. All right, so it's an Excel spreadsheet. I'm just going to show you briefly what this coral temperature spreadsheet looks like. So after inspecting, I can see that we have a header line, we have some units in the second line, and right off the bat, I see I'm probably going to want to change this date format to be an ISO 8601 date for interoperability purposes. So that's something I'm going to be looking out for after I load the data. And you'll see that there's a bunch of sheets here. One is metadata, and then a whole bunch of other kinds of data, but I'm just going to be loading some temperature data. And so I've chosen the file, and I said it's the format Excel. We have a whole bunch of other configurations that I've already set to say skip the second units line. I'm just going to run that load step. And what I was saying before is the power of visualization. So I can see this data table. I have some nice tools here, like a summary view that will show me the first lines, some random lines, and then last lines. I can filter and can interrogate that way. So we can do some quality checks with some basic statistics. And it won't be meaningful until I set the types to say what's numeric and etc. But we have all kinds of kind of immersive tools to make sure we're doing correct data management. And the cool part is that after we apply transforms, we can keep looking at this table and seeing how the changes we've made affect the data. So for example, I mentioned I want to change that date format. So let's go back to the Excel file. It says this is the format of date, which is a little misleading since it actually doesn't have slashes in it, but it's from this I can gather that it's month, day, 4-digit year. So that is what I put into as the input format. I'm telling it I want to type this as date, and I want to output this, which is ISO 8601 format. I'm gonna, you know what? I'm gonna transform it in place instead of make a new field, just because I want to show you the dynamic table view. So sorry for jumping around here. Give me 1 second because I want to show you how this updates. So I have the date column here. I'm going to run this date transform, and I'm not changing time zone, but that is possible to do. So you'll see now I have the date is now transformed into ISO format, and it's typed as date, which is important for doing statistical calculations on what's the maximum of a date. And now I'm going to set the other types. Let me just set types. This is going to infer. And so this gives its inference based on, I think, the first few lines. Conrad maybe can correct me on that, the first maybe a few hundred lines, but I've already run this pipeline quite a bit, and I know that I need to make these actual support decimals. So I'm going to do number format, and I'm going to set the type. So I'll see in this data table, I still have a lot of things as string because I just loaded that as the default load. And I'm going to set the types. Oh, and it's giving me an error with some very useful feedback, which is telling me at this row number, this tank can't be set as integer. And this is a common thing with things we encounter with stations or labels like this, like identifiers, that it might look like an integer at first, but actually it should be termed as strings because they put things like A or B like that. So I'm going to adjust correct course and say this is actually a string. Let's try again. see if we got all the things. So ran so successfully. We've got our typing set correctly. Let me just run some statistics. So I'll get some basic statistics, max, min, and we have potential to do some other more complex custom statistics, like if we need to make a unique species list, we can download a separate file or just view the species. That's important when we're doing name resolving and things like that. And then this other thing you see with a red exclamation part is telling us that we ran a good tables validation check that came back with an issue. The validation is, frictionless validation is, there's a lot of them that are out of the box very useful, but this is another case where this is a custom check that we've decided we wanted to add to check the names of all the columns to see if they conform to Bicodimo's naming conventions, which this is showing me the columns that don't conform to that. We will replace like spaces with underscores, not have punctuation in the names, not have them start with a number, things that support interoperability in a number of applications that users want down the line, like MATLAB, or if you want to program in C. So we have naming conventions to make sure everyone can use these data after they're dumped from the pipeline. So I think we've probably gone through our time, but we can find and replace or rename the columns directly, or use regular expressions to rename the column names. But so, and then dumping the pipeline produces, like Adam was saying, those combination of files. So we have the pipeline spec, which shows captures the instructions of the pipeline itself and allows you to rerun the pipeline. And then the output of that is the coral temperature CSV, which is in a format that anyone can use. You don't have to have a specific application to use CSV. Anyone can use this. It's democratized. And the data package JSON, which is the metadata that provides context and describes that data file. So I kind of just went fast and furious through that. And I think that's the end of our time. Or are there any questions about this part of this? Okay.
Yeah. So it's great to have this time now, because we can sort of answer questions that are important to you, or we can show you all the processors, or this time is really for you to get what you need out of this. So yeah, we're happy to help in any way or answer any questions.
Right. Like Adam was saying, that behind each step is a snippet of code, and some are out of the box frictionless transforms, and some are custom ones that we have, which is actually they're in a public GitHub repository, which I think we have the link to in the agenda, that if you wanted to reuse some of the custom processors we've made, that's public. Yeah. And so just in terms of democratization of the ability to do the data processing, one of the big effects of having this tool in our group is that there were certain types of data sets that not all the data managers would necessarily take because it wasn't in their programming strength, but everyone is comfortable using this now, and as long as you understand the transforms, that's the important part. As long as you understand what the transform does and the effects on the data, that's all you need to use this tool. You do have to know regular expressions, which we've all been beefing up on that. That's probably the biggest technical barrier in our implementation of this.